So the next one now, they want us to find the domain and range of this function here. That is, I like using the word they too much, I'm sorry. We want to find the domain and range of this function y equals x squared over 1 minus x squared. And the domain of a function, let's go for the domain first. We want to find the domain first. The domain of a function is the set of all values of x. That is if the function is built on x. That is if the independent variable is x. If it were to be other variables, then you just make use of that variable. So the domain of a function is the set of all values of x being x here, being a variable, independent variable being x. When you have variables y equals something, then y is the dependent, whatever it's equal to is the independent. So x in this case is our independent variable. So the domain of a function are all values to which that independent variable is defined. Are you getting what I'm saying now? All the value of s for which the function is defined, yes, for which this function, for which we get a definite value for y. All values of s for which you get a definite value for y are we together here now. And you don't forget, back then in secondary school, say SS2 precisely, algebraic simplification, we say a function will be defined, most especially a rational function. That is all this fractional stuff. A function is defined once the denominator is not equal to 0. Now listen, every polynomial function is defined. Are you getting what I'm saying now? Be it y equal to x is defined, y equal to even constant function is defined at all point. Now, the only point where we need to be thinking of, the only issue we have as to function is when we have rational functions and some of these trig functions or whatever it is it can be. But trig is here. No, logarithmic function. Because there are some field you go to in logarithm that you don't have a definite value. But coming to this algebraic stuff, now the only part we have issues with as to it being defined or not is actually when you have a fractional or rational stuff. All this fractional stuff, don't mind me, fractional stuff. So when I have this fractional stuff, it is undefined at the point where the denominator equals 0. Because that's just like what I said in I think 1 or 2 of the videos I've made so far. I said when you have the denominator of a fraction to be 0, at that point it will not give you a definite value, because we say any number divided by 0 is undefined. So it is undefined when the denominator equal to 0. So what do you need to do? Once you are told to find the domain, just go to the denominator and look for the value of s for which that thing is going to be equal to 0. And how do you do that? Just set the denominator equal to 0. So setting the denominator equal to 0, that will be 1 minus x squared equals 0, which is the same as x squared equal to 1. So s is going to have two values because of the degree. The degree is 2. That will be plus 1 or minus 1. Now this function is defined at every point in x, at every point in real number except the point minus 1 and plus 1. So we can write it like this. This is the domain, or write it in interval form. Are you here? So it is defined at every point in x from 0 to negative infinity, and from negative infinity to 1, and from 1 to positive infinity. Somebody is saying, what about, why did they put 1 here? Don't forget, we are talking about real numbers. There are a lot of numbers between 0 and 1. Should we just say minus infinity to union 1 to infinity? That's wrong, because there are some number in between. What of 0? Are we trying to say 0 is not there? No, it is still defined as 0. So now, and you don't forget that this is an open interval here. This is an open interval, that is, it will not get to 1. It will not get to 1. It's just that point. With the interval we wrote here, we are still telling you that point, it is the same as what we wrote here. Point minus 1 is not there. An open interval means it will almost get to that point where it will not reach that point. But at we use a closed interval, then that's where the problem is going to be. I get what I'm saying here now. So we use an open interval. So this thing here and this thing here, they are the same thing. So that is the domain of that function. We want to go to the range now. So the next thing is for you to find the range of this function. We want to find the range of the function. For you to get a range, just set x equal to, x being the subject of the formula. And from there, for all values of y to which we are going to get a definite value for x. That's what the range is going to look like. All together here, because don't forget, from the idea of function, X, set X is the domain, set Y, which is the codomain. From there we get the range. So the range has to do with Y, while the domain has to do with X. So for all values of X to which we are going to get a definite value for Y is our domain. While values of Y to which you get a definite value for is something matched to it, a definite number matched to it from X, or you get what I'm saying? Like when you have this domain functions thing. So from there, that is where we get the range from. So what we need to do here is just to make Y subject of formula, X subject of formula, and you can equally make X squared subject. Altogether here, X squared, you can equally make X squared subject, and you can make X subject. Either of the two. So making X subject, what do you need to do? Just make it from here. We have Y equals X over 1 minus X squared. Cross multiply. I will get what I'm saying. So that will be this one multiply this being the denominator, which is not visible. This one will multiply this, yes. So that will be Y into bracket 1 minus X squared equals X squared. The next thing, open a bracket, Y minus Y X squared. The next thing, just bring all the X together, because you want to make X subject of formula. So from there you have Y X squared. We brought this one here. You get what I'm saying now? So we say we have, is either you bring the Y first, or anyhow you want to do it. 1 plus Y squared is the same as Y squared plus 1. Anyhow you feel you want to do it. So that is that. So we factorize X squared. Then I left it what? X squared equals, dividing both sides by Y plus 1. So S squared equals Y over Y plus 1. S squared equals Y over Y plus 1. So X is going to be the root of Y over Y plus 1. Now the thing is, we want to look for the point to which this thing is divine. Altogether here, that is what we are after. The point to which this particular expression is divine. So the domain of this function, are we together? The domain of this function, we don't forget that we said our X is actually root Y over Y minus 1. So sorry, the range is just all the values of X. You're going to put into this thing to get a corresponding beautiful value. All the values of Y you put into this place to get something divine for X. Now the thing is, think of numbers. If you put anything negative here, think of minus 1 over minus 2. If you put a negative number, if I put a negative number here, that will be a minus 1 over a minus 2. If you put a minus 1 over minus 2, that will still make it positive. Yes. Minus 1 here over minus 2. Wow, that's beautiful. Now, we need to check the different scenarios before we eventually, I brought, this is a plus, please, a plus. There's a plus there, not a minus. That's the mistake I made. So, being positive now, if I put a negative number here, let's say I put a minus 1, and I put a minus 1 here, that's definitely going to spoil the show. Minus 1 plus 1, that's 0. And minus 1 divided by 0 is what? Minus 1 over 0 is infinity. Square root of infinity, we don't know. So, and any other negative number you put into this, by investigation, that's how we do it. Any other negative number you put into this, say you put minus 2, and then minus 2 plus 1. At the end of the day, you keep getting values that eventually may not match for negative value. Because the thing is, we don't have a square root for a negative value. And that's where the problem lies. I want to get here now. That's where the problem lies. So what we're going to do here is that the domain is going to be from 0 to positive infinity. The range is from 0 to positive infinity. The domain is from 0 to positive infinity. Just look at the point where the denominator. Now, talking about these points, if we said it will not be divided at the point where the denominator equal to 0, that's one thing we know. So Y minus 1 equal to 0. And another thing, this thing should have been an easy thing if wait not for the square root. We need to understand that. So you having a square root now, you need to be careful. Can I get square root of a negative number? No. Can I get the square root of a negative number? No. Okay, but there are still some values you can put here so that we get a definite value. Are you getting what I'm saying at all? There are still some values to put here so that you get a definite value. But the domain of this definitely from 0 to positive infinity will work well for the range of this function having a root, because we cannot get a square root of a negative number. That ends that.